Alright, so in this video we're going to go ahead and look at 8.1, day 1 of sequences and series, and today we're going to be writing the terms of sequences and determining the nth term of an expression from sequences and from recursive sequences. So, some vocabulary and definitions that you want to make sure you pause the video to get down. A sequence is a collection of numbers that follow a particular pattern. You can even say just the numbers 1, 2, 3, 4, 5, and so forth. That would be a sequence that follows a particular pattern. The individual elements in a sequence are called terms, so that individual numbers. So again, if I use the example of just basic sequence 1, 2, 3, 4, 5, and so forth, that would be a sequence. It's following a pattern. I can see where it's going. And each of these individual numbers are our terms. An infinite sequence would be a sequence that continues on forever. So like my sequence up here would continue on forever. I see my dots indicating it goes on and on. A finite sequence has a specific set of numbers. So if I just do the numbers 1 through 6, 2, 3, 4, 5, 6, that is a finite sequence. It just went up to the number 6. It had 6 individual terms. The notation that we're going to be using is A sub n, which means that the n stands for the term number. So like A1 would be my first term, A2 second term, A3 third term, A4 fourth term, and A sub n we call the nth term, where n stands for the number of terms in a sequence in a finite sequence. Okay, so that is our notation. So we're going to go ahead and find the first 4 terms of these sequences here. Super easy. Literally all we have to do is just plug in the numbers. Remember, n stands for the number of the term. So if I want to find the first 4 terms, then I'm going to find when n is equal to 1, 2, 3, and 4. So I'm going to find A sub 1. Well, that's just 3 times 1 minus 2. 3 minus 2 is 1. A sub 2. 3 times 2 minus 2. 6 minus 2 would be 4. A sub 3 would be 3 times 3 minus 2, which would be 7. A sub 4 would be 3 times 4 minus 2, which would be 10. And that would be the first 4 terms of that sequence. Now I can go ahead and do the same thing on this one again for n equal to 1, 2, 3, and 4. So we're going to have A sub 1 would be 3 plus negative 1 to the first power. Well, that would be the same as 3 plus negative 1, so that would be 2. A sub 2, I would have 3 plus negative 1 squared. That would be 3 plus 1, or 4. A sub 3, my third term, 3 plus negative 1 cubed would be 3 plus negative 1, down to 2 again. And A sub 4, 3 plus negative 1 to the fourth would be 3 plus 1, or 4 again. So this one actually oscillates back and forth between 4 and 2. Alright. So, write the first 5 terms of the sequence. So this time my n is going to be for 1, 2, 3, 4, and 5. In light of time, I'm only going to do the first 3, and you will need to finish up the last 2. So I have A sub 1. I would have negative 1 to the first power over 2 times 1 minus 1. Well, negative 1 to the first would be negative 1. 2 times 1, 2 minus 1. And I'd have negative 1 or 1 or negative 1. So I found my first term. So we have a to the second would be negative 1 squared over 2 times 2 minus 1 would be positive 1 over 4 minus 1 or 1 third. A to the third, I would have negative 1 cubed over 2 times 3 minus 1 to give me negative 1 over 6 minus 1, which would be negative 1 fifth. Notice we go negative, positive, negative. Next one, A4, should be positive, and then A5 should be negative. When we alternate back and forth between positives and negatives, that happens because we have something like this, negative 1 to the power of n. Because as n changes from even and odd, it changes positive and negative. Alright, let's go ahead and find A4 and A5 on your own, please. Alright, so we want to go ahead and write the expression for the apparent nth term of the sequence. Way that we're going to go ahead and do this is these are my a sub n terms. So we have a sub n is 1, 3, 5, and 7, and our n terms would have been 1, 2, 3, and 4. So think about like one of our problems that we had here. We had this expression that we were then able to plug in my nth terms and get values outputted. And so I could have written this in the n as 1, 2, 3, 4, 5, a sub n as negative 1, 1/3, negative 1/5, and so forth. And so that's what we're going to do here. And so the thought that we need to have is, how do I take my n? What can I do to my n to get a sub n? What would I do to it? And it has to be the same all the way around. Well, if I notice, and you're going to kind of have to play around with your numbers, try a couple different things. You might say, all right, well, 2 plus 1 is 3, but 3 plus 1 is not 5, nor is 4 plus 1 7. You might say, okay, well, maybe I can times it by 1. 1 times 1 is 1. But then 2 times 1 is not 3, and so forth. And so you have to have the same thing that it can apply to all of them. And if we look at it, we can see that we're actually going to times by 2 and subtract 1. And that would actually work. And we can see that 2 times 1 minus 1 is indeed 1. 2 times 2 minus 1 is indeed 3, because that'd be 4 minus 1. 2 times 3 minus 1 is indeed 5. And 2 times 4 minus 1 is indeed 7. So the expression that we would write would be a sub n equals 2n minus 1. The n is what we're changing, what we would be plugging all our n terms into. Alright, so we're going to go ahead and do the same thing here. We have our n terms, 1, 2, 3, 4, a sub n, 2, 5, 10, 17. And again, we want to think, what can I do to n to get me to a sub n? And so I think, okay, well, 1 times 2 is 2. But that doesn't work here. 2 times 2 is 5. Let's try something like we did on the previous one. Oh, maybe 1 times 3 minus 1. Well, 1 times 3 is 3, minus 1 is 2. Oh, maybe that will work, because 2 times 3 is 6, minus 1 is 5. Oh, it seems like we're matching these two, but when I get here, 3 times 3 is 9 minus 1 is not 10 but 8. And so that doesn't work. So we have to keep thinking. Maybe it's some other operation. Remember, we have a lot of operations at our disposal. We have adding, we have subtracting, multiplying, dividing. We have powers, we have exponents, we have a lot of different things going on. And so if I use maybe powers, I can try instead, maybe if I square the number and add 1, would that work? Let's see. 1 squared plus 1, yep, that would be 2, that matches. 2 squared plus 1, 4 plus 1 is indeed 5. 3 squared plus 1, well, that'd be 9 plus 1 is 10. It looks like it's working. And 4 squared plus 1 would be 16 plus 1 and 17. So that works. So our expression would be n squared plus 1. All right. So I want you to go ahead and try these. Same exact thing. Go ahead and write your n values above your a sub n and see if you can find the pattern. How do you get from 1 to 3, 2 to 7, 3 to 11, 4 to 15, and so forth? The fraction one is a little bit tricky, so maybe we'll do that one, and I'll leave you to have C. So if I have 1, a sub n would be 2 over 1, 2, 3 over 3, 4, that would be 3, 4 over 5, 4, 5 over 7, and 5, 6 over 9. Well, for a fraction like this, you have to actually think about two different patterns. What can I do to n to get the numerator, and what can I do to n to get the denominator? If I think about the number is actually pretty easy. All I have to do is add 1. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and so forth. So my numerator is easy. All I'm doing is adding 1. What's going to be tricky is the bottom one. We have 1 to 1, 2 to 3, 3 to 5, 4 to 7, 5 to 9. Well, maybe we can try, if I notice, let's see, I had it here. Do we recognize those numbers? 1, 3, 5, 7, 1, 3, 5, 7. We've already seen that pattern happen right here, and our pattern was times 2 minus 1. So on the bottom we would have 2n minus 1. And so you just have to think about each, the numerator and the denominator, kind of as two separate patterns. And so our expression would be n plus 1 over 2n minus 1. Alright, now we're going to go ahead and talk about recursive sequences. In a recursive sequence, these are sequences where all terms are defined by using the previous term. So if I say I'm going to add 1 every single time, well then I would say, okay, I have 1, 1 plus 1 is 2, and then I use 2 and say 2 plus 1 is 3, and then I'd say 3 plus 1 is 4, or I can even do something like, I'm going to square the previous number. So 1 squared is 1, 1 squared is 1, and so that just gives me 1 over and over again. Let's see, let's try something else, maybe times 2. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and then 32, and so forth. So recursive sequences are defined using previous terms. And this is kind of how we write it out. We use the k's instead of n's, and we're going to represent that if I want the next term, so k plus 1, I'm going to use the current term k and minus 9. That's what that would say. So if I was to do something, I would say, well, for these you actually have to give the first term defined. So let's say my first term is 5. Why not? Well, my next term, I would have to use that previous term and subtract 9, and I'd get negative 4. And then if I want my next term, I would have to use the previous one result that I got, negative 4, and minus 9, and I get negative 13. And if I wanted to continue, I would have to use the result to find my next answer. That's how recursive sequences work. So we're going to go ahead and find the first 5 terms of each sequence. So I'll do a couple and I'll have you finish that up. So again, like I said, we always have to have the first term given to us. So a sub 1 is given. A1 is 15. Well, if I want to find a sub 2, I have to use the previous number. If we think about that, 1 plus 1 is 2, so k is equal to 1. So I use my value for a sub 1, 15, and I add 3, and I get 18. Well, if I want a sub 3, I'm going to use my previous result, 18, and add 3 to get 21. So you need 5 terms. We have 3 of them already, so go ahead and find a sub 4 and a sub 5. Again, recursive sequences using the previous term to find the next terms or subsequent terms. Alright, so same thing here. I'll start it out, maybe the first 2 this time around. So we have a sub 1 is 32. So if I want to find the next one, I'm going to use my previous term and times it by half. So the half of 32 is 16. A sub 3, I would take 16 and take half of 16, and that would be 8. And again, you'll need to find a sub 4 and a sub 5. Again, we're taking the previous one and cutting it in half for that sequence. Alright, so for this one, we're going to do exactly what we just did. I'm going to write out our first 5 terms, and then we're going to use a pattern to write the nth term of the sequence. So we're going to kind of combine what we did on these 2 problems, example 4 and example 3 here, and combine it with one of these type problems. So we're going to do this first, and then do what we have here, finding that general form. So we're going to go ahead and find my terms. So a sub 1 is 25. A sub 2, I look over here. Okay, I'm taking that term and minusing 5. So 25 minus 5 is 20. Alright, a sub 3, I take 20 minus 5, I get 15. And then if I want a 4, I take 15 minus 5, get 10. And a sub 5, I take 10 and minus 5, and get 5. Alright, so there's my first 5 terms. Now I want to write the expression for the nth term. So I'm going to write out, I had n was 1, 2, 3, 4, and 5. And my a sub n is 25, 20, 15, 10, and 5. Nice thing about having a recursive sequence is that we can actually use it to help us find what we need to do to my n's to get my a sub n's. Because if we think about it, on each of these over here, we subtracted 5 every time. So if I think about this first one, I minus 5, I minus 5 again, but if I think about it in total, I would have minus 10 from the very first one. And then I would have minus 5 again, so that would have been minus 15. And then maybe minus 20. And if I think about it, if I go from the very first one, minus 20 gives me that one. And so I see that these minus 5s are kind of piling on top of each other. That represents a linear growth or a linear decay or pattern here. So I know I'm going to be minusing 5 a certain number of times. Okay? So if I know I'm going to be minusing 5 a certain number of times, if I see the 5 repeating, that's going to be kind of my slope. I can think about it as slope. So I'm going to have 5 times my n. But if I just do that, a sub n equals negative 5, and that doesn't work because then a sub 1 would be negative 5, and that's not what I have. I have 25. So how can I make this work so that my result when I have a sub 1 is 25? I know I'm going to have minus 5n. Well, maybe I can have 30 here, because I know if I plug in 1, that would be 5 times 1, and then I would have 30 minus 5 would be 25. Let's see if it works. A sub 2, 30 minus 5 times 2, that would be 10. 30 minus 10 would be 20, and that works. And 5 times 3 is 15, and 30 minus 15 is 15. 5 times 4 is 20, and 30 minus 20 is 10. So that would work. So my expression would be 30 minus 5n. And again, I got the 5n because I was minusing 5n all that time, several different times of minusing 5n, and that's kind of compiling. And when you have a repeated subtraction, it becomes a multiplication here. Okay? So, you want to go ahead and do this one here, and that will be the last one. So go ahead and try that. Again, you're going to go ahead and list out, you're going to list out the recursive terms, and then try to find the sequence. A hint, you're going to be multiplying by negative 2, repeating. So if you're repeatedly multiplying by negative 2, repeated multiplication results in exponents. Like maybe negative 2 to the power of n. You might want to see if you can apply that here. Alright? So, there you have it. Those are your notes for day 1 of 8.1. Make sure you get all those notes. And thank you for watching.